Good morning, everyone. KN4MDE with Radioactive. We are out here at Flint City Park, and as you can see behind me, we got KC5RFU. We're setting up his satellite system, give it a dry run before field day. Make sure everything's going to work all right on it. See here if I can flip this around so we can see. Hang on just a moment. All right. You see this element here, and he 3D printed each of these clamps. And commercial UHF on this side. Paul, hope you don't mind being on video.
No, I'm good.
Okay, you say hi to everybody.
Hello. Hi, Mom.
And if you don't mind, you want to tell them a little bit about your setup here and what
Sure.
we're testing?
It's a typical satellite setup, VHF, UHF. It's kind of a thing that I put together. I started working satellites back in 2014, and I was like everybody else. I was using the Arrow antenna and a handheld, working the FM birds, and then not being able to afford, $1,000 for a Yaesu rotator, I came up with a design. I built a homebrew rotator out of robotics parts, and it's controlled with an Arduino. Well, I don't have that out here today. I'm using a commercial version that I found cheap at a Hamfest. But it is controlled by an Arduino. And I'll show you that setup here in just a few minutes. The VHF antenna is called a cheap Yagi. You can find the design on the internet. Just do a Google search to cheap Yagi. The one I have is a cross version. It's actually two that are put together. And I have a phasing harness. These two cables are RG59, they're 75 ohms, and then the delay harness is a short piece of RG58, and that provides a delay between this element and this element. And then what happens is, in theory, you have the right hand circular polarization, and that's important when working satellites. A lot of people use just a single polarization, and you get a lot of fading in and out. This prevents that from.
Okay, as the satellite's rotating,
as the satellite's rotating, yes. Then it stops a lot of the fading that you will get.
And you said the VHF is called a cheap Yagi?
A cheap Yagi, yes. You go in any search engine and you can look it up.
Okay, we'll try to put a link to that in the description on the video as well. All right, we've moved over to the finishing setup over here. All right, and we've got battery to run everything over here. Now, what do we have battery-wise?
Okay, batteries, I have two separate batteries. One is a Bioenno 30 amp hour lithium iron phosphate battery. That'll be used with the radio. This one is a homebrew unit that my son-in-law did for me. He has a little battery business on the side, and it's four 3.2, 3.3 volt cells, and they're all tied together in series, and the capacity is roughly about 50 amp hours. Now to add to that, I don't have any sunlight yet, but I also have a solar panel controller, and I have a set of solar panels that I'll be hooking to this battery. This will run the inverter, DC to AC, and this will be used with the laptop, the rotator controller, and in anything else that I have that requires AC power.
Okay.
Hey,
We got his rotator controller here. Still getting set up and ready for this. I'm going to be cutting in and out during the setup. A lot going on here. A lot of people testing stuff before field day. Hopefully we'll have this video online before field day.
I'm only the one that I kept. You know, remember I kept like 2 of them and you got the rest.
And of course, the heart of the setup, the ICOM IC 9700.
Ah, okay.
Clean up the table here, and I'll get some of this set up here.
All right.
You know, I've got the 9700. I'm not working satellites. I'm going down to the east just to see what I hear.
And we got stuff going on over here too.
Monitoring, and me and the grandson
People setting up
was
over
doing
here.
some little project, making notes.
Play around this morning. Got the 12-meter spider beam going up over there.
I went back over and checked on that. It
People
had
standing around talking.
FT8 transmission.
A lot of coffee being consumed.
2 meters south.
Yeah, all kinds of testing going on. KD8 PZT has the spider beam out. If I don't fall over trying to get to the top of it. Over here doing a little POTA hunting on the
This is an abbreviated one I carry when I go do like a photo activation.
7300 set up over here. Hunting POTA.
He came prepared. Okay, call signs
Is this
on
for
the back, and
continuous?
I put a list of the basic equipment,
PZT.
so that'll help you remember. I think I've got everything except the ability.
Okay. Are you having trouble getting the radio to talk to the software, or?
No. Well, see, that SAT-32, I don't remember what kicked me off of it, but I gave up. I use ham radio deluxe, but it is basically useless for satellite control. But it
All right. About to get set up and going here. Now, out here on this tripod, this
That is a GPS module that is connected to the K3NG controller. It tells the controller where we are, when we are, and it provides more accurate positioning of the rotator.
okay.
And you can see
That's
it's
it
time.
right there.
It's Zulu time coming from the satellite GPS, and also our grid square. Echo Mike 64 Mike Mike. And let's see. Showing azimuth 180. Let's go check that. Oh, we gotta turn that on. Okay, 90 degrees. Showing azimuth of 50. That's not right. So we're gonna have to make adjustments on that.
ICOM IC 9700 here. Going to make an adjustment. For some reason it's showing the azimuth a little bit off on it. It's showing 50 degrees and it's obviously setting at 90 degrees. And we've still got some POTA hunting going over here behind us. was field day already. When in reality, this is just to warm up and test everybody's equipment and see what's going on before field day.
Normally I use a headset, but I'm going to use a desk mic today, so everybody can kind of hear the satellite as it's going down like it's coming back down.
And what software are you using to control everything here?
SAP PC 32. What I do first is connect up the rotator controller and the radio and check and make sure that the computer is actually seeing it. There's the radio, and there's the Arduino, the rotator controller, so we're good there. Make sure which port that's using. COM5, okay. So now we'll go to SAT PC 32. Here's the satellites that are coming and the time before they come, 14 minutes. Or this one's actually actually passing over AO27. AO91's coming in 9 minutes, and these are all sequential as in the future. They're all what times they're coming. This is the maximum elevation at which they would be passing over. So let's go to AO91, which hasn't been really a performer here of late. It's kind of hit and miss on it. I'll turn the radio around. So the first thing we want to do is check our rotator. We'll go down. Close right there, close enough to do what we want to do. Let's check my azimuth.
satellite. There's when they're passing over. Switch sides here.
Kind of hard to see with the reflection,
Yeah.
but there's some buttons at the top. The rotator control is R. You would hit that to start the rotation once the satellite is in view. The cat control, you click it, and the radio starts, automatically sets, and it starts doing the Doppler control. Now for FM birds, what I do, and not everybody does this, what I do is let the rotator be controlled by SatPC32, and then I'll do the same thing as you're doing with a handheld. I'll set the, for AO91, I will set the downlink frequency, and then I'll tune the uplink frequency in steps, just like you would if you had a handheld and an arrow antenna. And I've had pretty good luck with that. Doppler correction for FM birds is not really that great with SatPC32, so that's how I do it. It works for me. So about another 4 minutes here, and we'll see how it goes. So another thing I look at, there's a file here in the computer. Usually I use two monitors. I have a separate monitor to kind of split the screen. So there's a cheat sheet of all the satellite frequencies that I use. Satellite. It's done by KE0PBR, and it's free. You can get this online. And what you look at is your uplink and downlink frequencies. For AO91, and we have to put the tone in there, we'll do that in just a second. Your uplink, I'll be adjusting this as the pass goes across, and the downlink will be set to 145/960.
Oh, it's North Carolina. No, you don't have them.
Okay, so now I will go there and turn the cat control off. And so starting out, we'll go at 435, 240, and then increase it up as the pass comes across. And the other thing we need to do here is go into menu, function, tone, turn the tone on, and then make sure that the tone is at 67 Hertz, which is what's required to get into the satellite. So that's all done. And we'll be listening. There are two different channels here, the main and the sub. We'll be listening through the main.
Now, the cheat sheet you got right there, you can send me a link to that. We'll put a link in the video as well for that. So we'll have a link to the Cheap Yagi and that as well in the video.
You can Google right here at the top, KE0PBR frequency cheat sheet, and it's on his website, and it's a free, it's an Excel file. It's a free download.
Okay. We'll put links to those.
So now that we've done all of that, it's going to do what's called a flip. The elevation is going to flip over 180 degrees, and then it's going to track it backwards. That way the rotator doesn't have to turn 180 degrees mid-pass. And for rotators that have the 180 degree elevation capability, that's very useful. It saves a lot of time in capturing the signal. Again, AO91 it's not really been performing well. I mean, again, it's hit and miss, so we may make a contact, we may not. Charlie 5, Romeo, Fox Uniform, Echo Mike 6-4. Kilo Charlie 5, Romeo, Fox Uniform, Echo Mike 6-4. So normally what would happen is if the satellite were working, I should be able to hear myself and see the signal on the scope of the downlink frequency, the signal coming in on the downlink. And it's just not happening here. And I don't hear anybody and don't see any other signals on the scope. can see here, the elevation should be 45 degrees. If you look at the antenna, that's very close to where it is.
This software, the little X marks where the satellite is, and the lit up spot around, that's where you should be able to hit it from.
This is the footprint of the satellite. This is the actual satellite position, and this is where we are. So if you look, it's almost directly overhead, not quite, but 60 degrees.
I've got it pulled up on Stellarium.
Yes, Solarium, right?
Yeah, I've got AO91 there.
Oh,
So-
I don't know if I can see it or not.
Oh yeah, it's kind of washing it
Yeah,
out.
kind of washing it out. I'm gonna have to cut part of this out. I'm gonna make people drunk watching the video. Ugh.
Yeah.
Just need some PBRs, right?
Don't even need them if you watch my videos. Hey.
How often does satellite come across where we can actually hit it?
It's at different times. This is an app that I have on the iPhone. It's called SatSat, and it can give you past predictions. This is the calendar that I have set for our location, and these are all the different satellites and the times at which they will come across and the maximum elevation of each.
Okay, so if AO91 is not working right now, we can try again in a couple minutes.
Try again the next time it will come over. It would be able to actually work it. It would be either later tonight or tomorrow. But again, AO91, they tell you don't operate it at nighttime because a lot of reasons for the technical problem is battery failure.
Oh,
So only operate it during when it's in sunlight. So the solar panels are running the onboard equipment.
is AO91 the only one that we can hit today?
No, actually, there's a linear satellite coming over here in just a few minutes, which is pretty reliable. I'm going to try. It's JO97.
Okay, awesome. And is this the 1001 there? Is that when it's directly overhead or when
That's when the pass starts.
Oh, okay. Okay, cool.
Yeah, these are all the start times, or what's called acquisition of signal (AOS).
Okay, and what is that app called? SatSat?
Yeah, SatSat is the app, and it's a free app that you can get. I used to be able to get it on the iPad, but they've not. I don't know why it won't. It got cut from the iPad, and you can still get it on the iPhone. Now, there for Android people, there's a program called Android Sat Free, I believe is what it's called, and it does basically the same thing. You put in all of your parameters, and then it'll tell you when the passes are going to occur in whatever area that you set it up for. The rotator control off, and in SatPC32, the rotator control, you have the ability, you can set it to wherever position you want, or you can click park, and the rotator is going to come back around and it's going to park back at where you set it, which in my case is 0 and 0.
Tap on it, but I don't know.
0 elevation and 0 degrees azimuth.
Okay, so if you had
It's a dial,
like
whatever.
satellites that you worked all the time, you could set your park to like near the start of the pass.
Yes, you could. But generally, Sat PC32 will start the pass about a minute before the satellite appears over the horizon. And now we'll go to JO97, and if you watch the radio, we'll click that, and then click the cat control, and it automatically changes it.
Oh, nice. And all that's controlled through the Sat 32.
Through Sat PC32, yes. And that's the cat tuning tab to make sure that we're set up with the right uplink and downlink frequencies. And also in this tab, what we can do is adjust. If our voice is high or low, we can adjust either the uplink or the downlink. In this case, it would be the uplink we would adjust. So to start out with, to check it, I'll whistle into the mic and see if I hear myself coming back. And I don't yet. Now going back to the chart. At 865, we should be at 435, 100, which means we need to tune the uplink down.
The system sells the software. The house company ton of data. You can know that's what I was here. It's like got free load and everything.
And of course, trees are going to be blocking the view there for, if you look behind you, it's, until I get past the trees, I may not be able to get into the satellite.
Which one is this?
Now,
JO97.
97?
about how much delay is there from you whistling into the mic to you hearing it
It's
back?
almost instant. There's almost no delay.
Okay.
125 milliseconds. We got to run. I was in the Air Force to run satellite charts. We had Lady Electric take care of that latency.
Yeah, this is supposed to be.
And I used to teach, I used to demonstrate just a little 9.6 asynchronous circuit. Run terrestrial, fiber, and then to run some journey up the satellite and back down the phone. And it's a whole type of
That's so cool. It's on the TV.
I don't hear anybody. I don't see any activity on the scope either, on the waterfall. hearing anything.
Alright, well, had a few issues making contacts with some of the satellites this morning. Had some issues with coax, getting that straightened out. Going to be testing a few more things with it. I'm going to go ahead and sign off on this. You can see the antenna back there behind me. I think he's fixing to reconfigure a few things and try again. I think we've got another satellite pass in about 20 to 30 minutes, and he's going to be playing with that. But we will get more footage of that, and we'll see that again come field day. And we will be hopefully live on field day. This will be with the Decatur Amateur Radio Club here at Flint City Park. Until then, I'm going to say 7 threes. Have a great day, and don't forget to get on the air and get radioactive. KN4 MDE, clear.